Okay, hi Year 11. We're about to start our next Extension 1 maths topic. It's chapter 14 and it's called Combinatronics. And this one is a new topic in terms of it's going to be full of stuff that you haven't seen before, which is, I'll press primarily what is happening with our extension topics. They're all new. Okay, so in looking at this topic, we're going to start with looking at this thing called factorial notation. Now, you may have heard of this before or seen it written before, but we have never used it in the junior school, and we're looking at basically an exclamation mark, and the exclamation mark is the symbol for a factorial. I'll show you in the calculator in a moment where that button is, but the definition of n factorial is what we want to have a look at first down here. So informally, for each whole number n, the number n with an exclamation mark called n factorial is the product of all positive whole numbers from n down to 1. So n factorial's definition is we start at n and we go down each number one by one until we get down to 1. So the number before n is n minus 1. The number before that is n minus another 1, which would be n minus 2, n minus 3. So far, we keep going all the way down until we hit 1, which is 3 times 2 times 1. Now, we don't know how big n is, so we don't know how far we want to go down from. So we generally just pop a few dots in the center, and that's enough to show us what n factorial is. And we'll have a look at some examples below. But 0 factorial is actually going to be 1. Now, we have buttons on the calculator to do this, and I'll show you where that is, that we primarily want to be not using the calculator for now and look at our algebra forms of this. So if I pop my calculator up there, there it is. This is on the abacus, and on the abacus there is a factorial button there. So if I wanted to work out, say, 6 factorial, I could on my calculator go 6 factorial, and that would be equal to 720. But what does 6 factorial mean? So I'm going to write that one in here. So 6 factorial, using our definition, is the number 6 multiplied by all the numbers below 6 until we get to 1. So that would be 6 times 5 times 4 times 3 times 2 times 1. Now what we can do is we could multiply all those out on our calculator. So let's just do it the long way. So that would be 6 times 5 times 4 times 3 times 2 times 1. Oops, can't quite get one there. And that is equal to 720. Now, our factorial button that we just had a look at a minute ago can do that for us very quickly. So instead of timesing all those numbers out, I can just go 6 factorial, and that will also give me 720. So that's what the factorial button is doing, and that's a really handy button to have because we might have a massive numbers like 700 factorial in which we can't manually multiply that down. Okay, 0 factorial is 1, but if you forget that, you've got your calculator again, and hopefully our calculators are okay with that. 0 factorial is equal to 1. So we've got that there, so we don't need to memorize that if we find that we can't. Now I want to have a look at a few examples below here. Yes, we could do these on our calculator, but I'm going to assume we don't have a calculator today, so we're going to look at this manually and have a look at what this actually means. So 11 factorial divided by 9 factorial. So 11 factorial is 11 times 10 times 9 times 8 all the way down to 3, 2 and 1. Okay, that's 11 factorial. And we're dividing 11 factorial by 9 factorial. So 9 factorial is 9 times 8 times 7 all the way down to 3 and to 2 and to 1. And what's great about writing them out like this, we can actually see what's happening. So when we divide these out, what we've got in common is the 11 factorial and the 9 factorial both have 9 all the way down to 1 on both of them. So what we can do is we can basically cross out this one with this one. They're cancelling each other out. And what we're left with on the top line is 11 times 10, which is equal to 110. So that's our answer to 11 factorial over 9 factorial. And you can check that on your calculator if you would like to. Now that's fairly straightforward. Let's have a look at B. B, we need to think a little bit. Okay, so we can't obviously do this on our calculator, n plus 2 factorial divided by n factorial, but we are going to use algebra. So using our definition of what a factorial is, n plus 2 factorial is n plus 2. What's 1 less than that? It's going to be n plus 1 times n minus 1 all the way down to 3, 2 and 1. That's our n plus 2 factorial. And we're dividing that by n factorial, which is n times n minus 1, n minus 2, all the way down to 3, 2 and 1. So what we have here is an overlap again, like in our previous question. Both of them have from n down. So these are going to cross out with each other. And what I'm going to be left with is n plus 2 times n plus 1, which I could leave like that or I could expand it, but I like it factorized, so that is my solution. Let's look at the next one. Okie dokie. Now, we don't have a calculator, so we need to work this out. Now, I am looking at that, and I'm just going to write down in long terms what that actually is. So we've got 1 over 5 times 4 times 3 times 2 times 1 minus 1 over 7 times 5 times 4. Well, actually, we might write them all in. We've got enough room there. 7 times 6 times 5 times 4, sorry. Times 6 times 5 times 4 times 3 times 2 times 1. And normally we'll get in the hang of being able to do this a little bit quicker without having to write things like this down. But for now, we're okay, I think, at writing it down. So we want to get this over a common denominator so that they're both over the same denominator. So I might just not skip a step there. I was going to skip a step. So we want them both over the same denominator. So we want to find the biggest number that both of these denominators go into, and it's going to be this one over here. So they're both going to go into 7 factorial. So 7 times 6, I'm just going to go and shorthand that one. So we want to put everything over the 7 factorial. Okay, so I need to bump this one here up to this one here. So I've got 5 down to 1, but I don't have 7 and 6 in there. So I've times this by 7 and 6 on the bottom. I need to times it by 7 and 6 on the top. The base here is the same as the base here, so it's going to stay the same. So what we have on the top line is going to be the combination of our two tops, because our bottoms can stay the same. And I'm going to write the bottom as 7 factorial now, because that looks a lot neater. So my top line is 7 times 6 minus 1. 7 6 is a 42, so I've got 41 over 7 factorial, and that is my answer. Okay, they're the ones in our notes for today, okay, but I want us to have a look in the textbook, and I'll pop some other ones into our OneNote to have a look at. But they're the ones that will get you through for this video. So jump into the OneNote, have a look at the examples I've popped in there, and have a look at the exercises that are set for you in the textbook. Thanks.